Would you like to understand how the stiffnesses of a motorcycle affect the performance? If the answer is yes, this video is for you. Today we are going to discover how the stiffness of a motorcycle affects our performance. However, first of all, we need to understand what stiffness is. The stiffness is a parameter that tells us the resistance offered by an elastic body to the deformation. The antonym is flexibility. So, to give you a practical example, if we were to consider a beam and we applied a load F to it, as it is shown in this picture, the less is the deformation D and the stiffer is the beam. At the opposite, the higher the deformation is, the higher the flexibility is. The stiffness is affected by the material, the shape, and the constraints on the structure. Yes, of course, we are talking about structures, because the motorcycle's frame, together with the engine, the tank, the seat support and the other components, make up a structure. These components are connected with different types of constraints which define the motion between the parts. Let us see what the stiffnesses of a motorcycle are. We have three types of stiffnesses. The longitudinal stiffness, this is involved when we brake and the green arrows represent it. The lateral stiffness, this is involved when we have a lean angle. The structure absorbs the road irregularities. It is represented by the blue arrows. And finally, the torsional stiffness. This is involved when the riders lean the motorcycle. See the red arrow. As we said initially, the response of the motorcycle depends on the resulting stiffness of the whole system. Let us have a look at the most critical structural components of the motorcycle. We could think to divide them into categories. In the first category, we put the most important and crucial structural component, and in the second, we put other elements that affect the stiffnesses but with less impact on performance. The most essential element is, of course, the frame. It represents the main structure and it supports most of the parts. Then we have the front suspension triple tree. It withstands the stresses coming from the front wheel. Often, depending on the motorcycle layout, the engine also provides an important contribution to the overall stiffness. Since the stiffness of this element is incredibly high, as a first approximation, we can consider it as a rigid body. It is between 10 and 20 times stiffer than the frame. Then we have, of course, the swing arm. It connects the rear wheel to the rear suspension and the frame. So these are the principal structural elements. Now we will see other elements that affect the stiffness of the system, but with a lower impact. The rider is still able to feel the difference if you make changes to those elements, and they could find one solution better than the other. Here we have the rear subframe, which supports the rider's seats. It can easily affect the feeling of the rider, and it can transmit more or fewer vibrations. Then we have the tank. Its function is to keep the petrol, of course, but since it can connect the frame to the rear subframe, it can have a relevant impact on the overall stiffness of the vehicle. Now that we have discovered the most critical structural components of the motorcycle, we can try to answer this question: how does the stiffness of this component affect the performance of our motorcycle? First of all, we have to consider that when we link stiffness to performance, we are moving on a very slippery field. In fact, since it is a matter of feelings, it is deeply affected by the rider's preferences. In fact, it is very common to see two riders competing for the same factory team, asking for completely different solutions. So we have to be very careful before coming to a conclusion. Anyway, we can trace a line in the mess. There are some guidelines that we can follow to understand how these things work. We are not going to look at any element apart, of course. It would be a heavy exercise. Instead, we are going to look at the whole vehicle by making general considerations. We will focus our attention on the lateral and torsional stiffnesses. The longitudinal stiffness is essential when we brake. However, rider feedback usually asks for a stiffest solution possible to provide a clear and sharp response in the first part of the brake. When the rider moves and forces the motorcycle to lean, we need to also lean the engine, of course. This element is heavy and stiff, so it does not want to follow the bike. If the torsional stiffness of the frame is low, the rider would claim that the bike is inaccurate, and they would perceive an inevitable lag between the input and the response of the vehicle. Generally speaking, by lowering the torsional stiffness, we would come out with a less sharp and more vague response. My experience showed me that different riders would have different tolerances to this behavior. We need to remember that it is not very easy to change one stiffness without changing the other. Coming to the lateral stiffness, we know that we need some flexibility here. When we have a high lean angle and we find irregularities on the road surface, this flexibility helps to absorb the bumps. We can play with this value to create a good coupling between the tires and the vehicle stiffness. Generally speaking, from a design point of view, it is essential to avoid concentrated flexibilities. To work well, we have to try to have a uniform distribution of stiffness. As I have already said, it is challenging to dominate this field. There are two main reasons. The first one is that it is related to the feeling of a human being, so the response is subjective. The second one is that it is strongly affected by the tires. A solution that is working well today could be useless tomorrow if the manufacturer provides tires with a different internal structure or compound. So the evolution of this field is continuous. So now you know how the stiffness of a motorcycle affects the performance. If you like to keep increasing your understanding of the motorcycle, keep following our videos. Tomorrow you will receive a new one. Thank you, goodbye.